Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and I've been requested by one of my third form to go over some of these problem-solving ratio questions that you've been set, part of the work that you've been set this week. I've put circles around the questions that I'm going to be doing from this worksheet towards the end of the worksheet, the ones that are actually really quite tricky. I'm not interested in things like this. This is far too straightforward. Question 23, you'll be able to figure that one out. Questions 22, 24, and then over the other side, 26. Specifically, just weirdly worded ones that just leave you thinking, what the heck am I doing? Let's start. The ratio of red cards to black cards in a deck is 3 to 10. 2 more red cards are added to the deck. The ratio of red cards to black cards is now 1 to 3. Work out the number of black cards in the deck. Yes, I've been looking at this and the other 2 questions I'm going to be doing today for quite some time, actually, a bit more time than I care to admit, because where do I even begin with this? Well, I know 3 to 10 is simplified, right? The ratio 3 to 10, it could well be simplified. It might be that 3 to 10 isn't actually 3 to 10. It could be 6 to 20, or it could be 30 to 100, right? It could be a version of the ratio that's just been simplified to 3 to 10. So effectively, both sides of this ratio could have been multiplied by something, and I don't know what that is. So let's use a letter to represent that. I'm going to use the letter X here. So 3x to 10x, it still simplifies to 3 to 10, but it just takes into account the fact that it could literally be any multiple of both of those things. I hope that makes sense. That's the way that I'm going to represent this ratio to help me solve this problem. Okay, 2 more red cards are added to the deck. Red cards. The first number in this ratio represents the red cards, because we know the order of the writing of these variables influences the order they appear on the ratio. So actually, 3x becomes 3x plus 2 because I've added 2 more red cards, okay? So far so good, just using algebra to represent this. The ratio of red cards to black cards is now 1 to 3. So this is the ratio, and I know that this to this simplifies, it simplifies to the ratio, let me check that I'm getting this right, 1 to 3, okay? It simplifies to 1 to 3. Now, I don't know how many multiples of 1 to 3. This 1 to 3, it could be 2 to 6. It could be 1,000 to 3,000. I don't know. So I need to use a letter to represent that factor that I don't know may or may not be at play here. Let's use, I don't know, the letter Y. See, I'm doing exactly the same thing to this ratio as I did to the ratio above, applying an unknown letter to it to represent that factor that I don't know about. Okay? Actually, now that I've got all of that information, I can effectively equate both of these things. I can write 3x plus 2 equals 1y, or just y, and then 10x equals 3y. Now at this stage, I've introduced some fairly complex algebra here to represent this problem, but it is a fairly kind of tongue-twisty problem, or brain-scrambly problem. This is the best way that I've been able to figure out to represent it. This represents the first number in the left-hand ratio, or the first ratio that we had, and this represents the first number in its simplified form. This represents the second number in the ratio that we had at the beginning, and this represents its simplified form as well. It makes sense that they're equal to each other. We solve these simultaneously, okay? I'm going to write the first one again, but everything in it will have been times by 3. So I end up with 3x times 3, 9x, 2 times 3, 6, and y times 3, 3y. Okay? And then if I include this 10x equals 3y, I can effectively subtract this one from this one. Okay, so if I write this on a perhaps an easier way to see, it's 10x take away 9x, and then minus 6, and then 3y taking away 3y equaling 0. Okay, so I'm left with x minus 6 equals 0. Now, this is a method called solving simultaneous equations. I don't know if my third form have actually gone through this yet, which is why this is an advanced question that I would only consider you to really have a go at if you really kind of are confident and want to press on in your algebra work. But x equals 6. What that means, now that I've got that value of x, I can substitute in to the ratio above, right? Because I know it's equivalent to the ratio here. Let's give this a go. So instead of 3x plus 2, it becomes 3 times 6 plus 2. And instead of 10x, it becomes 10 times 6. 3 times 6 is 18 plus 2, 20. 10 times 6 is 60. Okay? 20 to 60 is the actual value of the number of cards in the deck after 2 have been added to the number of red cards. And you might notice that simplifies to 1 to 3, which is exactly what the question says here. Red cards to black cards is 1 to 3. These numbers work. Of course, the question's asking us, what's the number of black cards in the deck? Well, the black cards number is the second one. So that's the number of black cards. Oops. So the number of black cards is equal to 60. Okay? Lots of stuff going on there, and I think there's more videos on this to come from me. But if you understand the process of using letters to represent the kind of multiples of ratios here, and equate it to the ratio that we're given in the question, the rest is just solving simultaneously. I hope that helps. I wish you all the best on the other questions in this exercise. I may well do another video. Yeah, keep on with the good work and get your work done on Teams. I will talk to you very soon.